In Lesson 1-4, Day 2, you'll be combining like terms and using the distributive property to simplify expressions. Like terms are terms that contain the same variables with corresponding variables having the same power. In other words, the variables have to be to the exact same power to be like terms. In this first example, we have 3 terms. In these 3 terms, we do not have any that have the exact same variable part, so therefore there are no like terms. In the second example, the a squared, the 6a squared, and the a squared are like terms because they both have a squareds. 2a is not the same because it's just a and not a squared. An expression is in simplest form when it contains no like terms or parentheses. Now, I sometimes like to think of terms as having first names and last names, the number part being the first name and the variable part being the last name. And if the last name is the same, then they're from the same family or they're like terms. If it's just a plain old number, there's no last name, those would be put together with others just like it. Let's take a look at the first example, simplifying 17u plus 25u. These two right here are both like terms, so we're going to go ahead and just add 17 plus 25. 17 plus 25 is 42. So this is 42u. In our next example, if we look first with the t squared, 6t squared doesn't have anything else that goes with it because there isn't anything else that is a t squared. So I'm going to go ahead and just write 6t squared. And then 3t and t, these two are like terms. However, when we go to combine them, you want to look at the sign that's in front of it. If there's a plus sign in front of it, that's a positive 3t. And here, if there's no number in front of the t, it's a 1. And it has a subtraction sign in front of it, so that's really like a negative 1t. Now, when I put those two together, a positive 3t plus a negative 1t is a positive 2t. Since it's positive, I'm going to write plus 2t. 6t squared plus 2t is the most we can do with this problem. You may want to pause the video now and try these next ones on your own. 6n, take away 4n, since they're both n's. We're going to simply subtract the coefficients or the numbers in front of the variables. 6 minus 4 is 2, and leave the variable part the same. It's 2n. This one right here is a little bit of a trick. We have a b squared, a b, and a constant. So here we don't have anything that is like terms, so we just go ahead and write simplified or can't. In our next example, we have 4y to the third power. There aren't any other y to the third, so I'm going to go ahead and just write 4y to the third. Now you can either use a different color or a different shape to put around the next one. We have a y, and we also have another one right here. So we have a positive 2y and a negative 8y. Remember to always include the sign in front of the term. So we have a positive 2y and a negative 8y. When we add those two together, 2 plus a negative 8 is negative 6. Since it's negative, we're going to write minus 6y. And then at the end here, this one just goes all by itself because there are no other numbers to put with it. 4y to the third minus 6y plus 5 is our simplified answer. All right, now if we move on to this next one, I'm going to go ahead and start with the squared term. The book doesn't really get into this yet, but usually when you write these out, you would put the ones with the higher exponent first. So I'm going to go ahead and put the negative 6a squared first. There are no other a squared, so it stays by itself. And then I'm going to move on to the a's. I have 7a and a negative 2a. When you put 7a with negative 2a, that is 5a. And then we have this plus 4. The plus 4 is going to go at the end. Negative 6a squared plus 5a plus 4. Now, if you would have just gone from left to right, you might have had your answer written as, let's see, 7a plus a negative 2a. You might have written down 5a plus 4 minus 6a squared. The thing that you'll want to look for when you're correcting your assignment on this is to look at the sign in front of each term, and you want to make sure that if it's a negative, you have a subtraction sign in front of it, and if it's a positive, you have a plus sign in front of it. In our next example, you're going to take an expression and write out the algebraic expression first. So twice the difference of 3x and y increased by 5 times the sum of x and 2y. Let's just go a little bit at a time here. Let's start with twice the difference of 3x and y. Twice the difference of 3x and y means 2 times the answer to the subtraction problem of 3x minus y. Because that's the difference of 3x and y, and now we want twice that, so it's going to look like that. We're going to have parentheses around 3x minus y and a 2 on the outside. Now it says increased, so we're going to put plus 5 times the sum, and sum means answer to an addition problem, so we want to put that in parentheses so you know to do that first. Sum of x and 2y, x plus 2y. Now part B is to take that algebraic expression and simplify it. It says to indicate the properties used, but you don't need to do that. What you're going to do first is multiply this 2 times 3x. 2 times 3x is 6x. And then 2 times a negative y. 2 times a negative y is a negative 2y. So remember, if there's no number in front of that y, it's really a 1. And then over here we have this here is a positive 5 times x, which is positive 5x or plus 5x. And then positive 5 times positive 2y is a positive 10y. After you get that far, you're going to go through and combine like terms. This 6x is going to join forces with this positive 5x. 6x plus 5x is 11x. And then we have the negative 2y and a positive 10y. Negative 2 plus 10 is a positive 8, so it's going to be plus 8y. So this algebraic expression, when simplified, becomes 11x plus 8y. If you want, you could pause the video to try this next one on your own. It says write an algebraic expression 5 times the difference of q squared and r plus 8 times the sum of 3q and 2r. So again, let's just take it one step at a time. 5 times the difference means that's going to be 5 times the answer to a subtraction problem, and it's the difference of q squared and r plus 8 times the sum, so 8 times the answer to an addition problem. It's the sum of 3q and 2r. Now to simplify the expression, we're going to go ahead and do distributive property first. 5 times q squared is 5q squared. 5 times a negative r, or 5 times a negative 1r, is a negative 5r, because 5 times a negative 1 is negative 5. And then we have a positive 8 times 3q. 8 times 3q is 24q. And then a positive 8 times a positive 2r is a positive 16r. Once you get that far, now you're going to look to simplify it more by combining like terms. This is my only q squared term, so I'm going to go ahead and just write 5q squared. Then we have a negative 5r and a positive 16r. Negative 5 plus 16, that's going to be a positive 11r. And then last you have 24q, and it's a positive 24q. And actually, I should really write this as 5q squared plus 24q plus 11r. Q comes before r, and the squared is going to come before the just plain q.